Does ambient RF energy suffice to power battery-free IoT? New innovations in IoT space are looking for ways to develop devices which are robust, compact, and most of all, batteryless. In recent years, researchers have exploited the technique of backscattering to introduce new battery-free IoT tags. Backscattering refers to a device siphoning the power from an existing RF transmission to send its own data. Traditionally, these systems have a dedicated high-power transmitter lying in close vicinity of the tag, which can be very infeasible to deploy at a large scale. This paved the way for ambient RF backscatter communication, which uses ambient RF energy generated by pre-deployed infrastructure for its power requirements. Lots of work has already been done in this space using LoRa, FM, and TV base stations. However, this raises some important questions like: is ambient RF power sufficient to power a tag ubiquitously? Also, what are the limits on the technologies which meet these power requirements? In this poster, we try to provide answers to these questions by performing a feasibility study of ambient backscatter communication in the real world. We take known base station locations for different radio technologies in few selected urban and rural areas to perform trace-driven simulations using Okumura-Hata channel model and calculate the net harvestable power at all these locations. We use the tag in the footnote as a baseline for its power requirement, which comes out to be minus 43.5 dB watt. We observe that almost 95% of area in Los Angeles receive less than the baseline power using FM base stations. The situation is worse for rural areas, as 99% of the whole area is below the baseline. In other words, we find that in most geographies, the effective area of coverage available for ambient backscatter is poor. Even if you use different technologies, the results are the same or may become worse for certain technologies, which is quite apparent in the cellular case. There can be many possible solutions to these problems: surveying the area before deployment, creating friendly FCC regulations, and innovations in tag hardware design to reduce the baseline. Find out more at the link given below. Thank you.